going to go through another example of our hypothesis test. So here we're given some information about they're helping customers set up their smartphones, and we have this goal of 96%. So the idea being, this is what we're going to assume the company is achieving. We're assuming it's achieving this 96%. What they're going to test is this new system, and here's our sample here. They're describing these 400 people, of whom 376 were successful. So there's our sample data. Is this strong evidence that the new system fails to meet the company goal? So right here, where we're looking for evidence of this certain event, in our case, it's the event that we fail to meet that 96%, that's outlining our alternative hypothesis. So our first step is to set up the null and alternative hypothesis. We're going to assume we're reaching that 96% goal. So we're going to assume we're at 96%. And what we want to find evidence for is that we failed to meet that goal. Meaning this 96% success rate is actually lower, significantly lower than 96%. So we want to show that this proportion of people that are successful is actually less than 96%. From there, we go and check our conditions. So independence, making sure the results don't influence each other, or noticing that 400 is less than 10% of all of their customers most likely. So we're going to have independence. Randomization, they don't clearly state that it's a random sample, but we're going to go ahead and assume that it is. And then for our sample size, taking our sample size of 400, multiply it with the proportion from the hypothesis, and also multiply it with 1 minus that proportion. So we're going to have these two values. This is going to be a 384. This is going to be 16. So because both of those are more than or equal to 10, we're good there. So we meet our conditions, which means we have a bell-shaped curve to work with here. This case, using the less than symbol, we're going to have a left tail test. Meaning when we go to find our p-value, where we have our standard normal curve, we're going to have a test statistic that's landing somewhere over here to the left. And to find our p-value, we want to take the area that's created to the left of that number. So this gives us an idea of where our p-value is coming through. And then our rejection rule is that we're going to reject that null hypothesis if our p-value is small. And for us, for it to be small, we look for a significance level, but they didn't state anything, so we just use 0.05. We assume it's that 0.05. So now that we have the setup, let's find the p-value. So if we're finding the p-value, we need to start with our test statistic. So with our test statistic, we start with our sample proportion, which for us, our sample proportion is at 376 out of 400, which is a proportion of 0.94. So in our numerator for our test statistic, we want to compare that 0.94 and subtract away our hypothesized proportion of 0.96. Then we divide by our square root of and use the hypothesized proportion times 1 minus that value, all over our sample size of 400. And when we plug this into the calculator, we should be getting a z-score of negative 2.0412. And again, once you get this test statistic out, kind of think in terms of our standard normal curve, where this is 1 standard deviation away, 2 standard deviations. If this is 2 standard deviations below the mean, that's getting into a significant region. So we're probably going to be getting a small area out. It's kind of hard, it might be on the line, but with this we get an idea that we might be rejecting that null hypothesis. To really be sure, we need that p-value. So using our standard normal curve, what we want to do is find the probability of seeing this value or even less. So we're looking for x less than or equal to that negative 2.0412. And when we plug that into technology, we should get a 0.0206 out. And this right here is our p-value. We get a p-value of 0.0206. And to see if this is significant, if it's small enough, we compare that number to 0.05. And we want to see, is the p-value larger or smaller? In this case, it's going to be smaller. And when we have a small p-value, we reject the null hypothesis. So, we have our significant results in that this sample that we saw, it's pretty unlikely to occur. This sample had a 2.06% chance of occurring if 96% is our value for success. So with that, we've proved the alternative. We have evidence that that's actually true. So with a p-value of 0.0206, there is evidence that the new system fails to meet the company goal. And that would be our conclusion.